Hello everybody. In this video, we are going to start working about collections and talk about the two different types of collections that we have in C#. We have the non-generic and the generic ones. Let's actually get started. So far, what we have seen in this class is how to create classes, pretty much, and how to give our custom properties, custom methods, and how to instantiate new ones. We learned also how to do interfaces and to work with different parts of those specific classes, pretty much, right? And it's cool. We were able to save a record about something, an element. Well, what about when we want to save a bunch of those? What about when we have multiple cars that we want to put together, or we have multiple persons, multiple workers? I don't know, everything that we saw so far. We want to actually create a group. Well, for that we actually have collections. And the traditional collection methods are the non-generic collection, where we have different ways to specify how to also actually going to be saved. And the most common one is actually an array. So let me just give a really quick example, and this actually came from the book. Let's do a .NET new console. Let's call this non-generic. Okay. I try to remove that one. Okay. And let's open it. I actually opening my other screen. Let me just move it. And give my computer a minute to actually process it. Perfect. You know what? Let me actually outside the non-generic one. Let me go to the folder, and now I can actually open it. Okay, that actually took in a lot of time. Okay, sorry for that. It looks like I have some issues with my Visual Studio Code. Let me stop the video and let me see what is actually happening. Give me a second. Okay, sorry for that delay. It took a lot of time to figure out what happened with my computer. But well, as you can see, I already have my Visual Studio Code open, and I just have the non-generic one, and I have just the example from the book about how to have an array. And as you can see here, I have a simple array with 3 elements, and those elements are strings. So we implement with the square brackets in order to say that it's going to be an array. We call it a string array, and we added 3 different elements in there. After that, we print out what is the length of the array, and then for every element in that array, we just print out that particular element. So you actually go to print first, second, and third in the new lines. Over there, we jump another one, and with those one, this is just a simple no generic collection, right? And we can have simple functionalities, for example, the reverse, that we can actually change the order, and we can actually just print those again as it is. So that's actually a really basic example. Let me actually execute it. .NET run, and it should be run. There you go. As you can see, we have the three items because we have the length, and we print in order, and then we print in the reverse order because we did reverse in line 18, right? It's a simple non-generic method. So those actually are really basic implementation how to handle a collection. Here we are saving several elements of string, and that string is saved in the array. Now, we have also some limitations because of that. Let's say that we can actually want to extend this array. Let's say something like this, right? Remember, array start with index 0, so we have 0, 1, and 2. So we want to add a new element. This actually is going to break. Let's execute it. And we have on handle exception, we get a system index our range exception here because the array is going to be extended. Not this way, not straightforward. There is now different methods to actually have those that will allow us to extend or not. So in order to work with data, you should have the fixed value at the beginning. So what happened before? Well, in the past, what you did do is you have like a really big array, and you allocate empty objects at the end, and you can actually add and remove data the way that you need it. But it's pretty much just assigning pre-saved spaces. Those spaces, of course, took time, took memory space, and made your code inefficient, right? So in order, the need to actually have those arrays to be a little more, or those collections to be a little more dynamic regarding the sizing, so we can actually expand about the content and go or be smaller if you remove some elements. It was actually collections came along, and we have a couple of namespaces for that. We have system collection where we have all the non-generic ones, and then we have the system collection generic. Well, of course, those names we have the generic one that we have there. So non-generic collections are typically designed to operate an object that are therefore loosely typed containers. It's how the book describes it. What is a loosely typed container is that you cannot do, or you cannot specify exactly like the value of the element inside of that collection. And for those ones, we have a couple of those. We have Arraylist, we have stack, we have queue, we have several elements that we can actually implement. In order to make this code a little more manageable, let me actually change it to use actually collections. So we have this one, the program, and let's call this. Then what I can do here? Let's create a new folder. Let's call this generic. Sorry. Let's call this simple array. Let's call this simple arrays. And let's create a new public void. Let's call this simple arrays too. Can we do this? Field So we need to have the class first. I was hoping to put this right away. So let's do class simple arrays. And let's have here the public void example. And this is actually not like this. What's happened when you type all that? For example, there you go. And let's copy all these elements from here, and let's put it there just to have it somewhere, right? And of course, we need to do the using system. Right? So we can actually do using simple arrays. We can actually do simple arrays. Oops. Equal new. This should be like this. Simple arrays. I'm missing the semicolon over here. And then we use SA.example. Right? What am I doing wrong here? Let's actually put this non-generic, the class. Probably have a problem with my implementation, so not generic there. We use not generic, perfect. We have an issue with because I was keeping the same name of the class and the namespace, so that's why I didn't show it. So with this, I just wanted to have the simple array elements outside somewhere else, right? Okay, cool. So we have the simple array. So the other one will be to have actually the array list. The array list is a little more robust example of a non-generic list. And what is actually happening with those array lists is a representation of the dynamically sized collection of objects listed in a sequential order. So those objects can be anything, and also can be accessed through the object itself, and can be accessed through an index. And there are actually benefits on those because it's dynamically allocated. You can actually remove or add element, and you will see what happened on the sizing. So let's do another class, and let's call this how can we call it in order not to overlap the name? Let's call this complex, but it's not complex in reality, just a complex array, just to have the name convention. And let's use in system. And because we're going to use a non-generically, we need actually use system collections. Perfect. And because of that, we can actually do namespace. Let's call this non-generic. So let's do the same namespace there, and let's do a class of, let's call this complex array. Let's have a simple public method being, call it go. How we call it the other one? Go example. and let's see what actually can give us to us. So in order to have an array list, as I mentioned before, that came from the collection itself. So we can actually do something really similar. Let's call it our string of array, and this actually came from the book too. But let's use a new way to have a new. So the difference here is that instead of having a simple array or a string like this, we actually specify with the array list. And as array list, I can just add a range, and I can do something like this. Let me just copy the line and paste it right here. So add a range is add elements in the collections from the array list, and those elements of our I collection, we can actually insert a traditional array that we have right here. And you know what? Probably we can do something like this. Public string array. Let's have it like that. So let's actually save it as, I'm gonna say it as a property, and that property is an array, and let's make this have get set perfect. So we're just making the array to be part of like a property here. That's it. And this is the method example. So we can, if we execute it, you will see that everything runs the same. We didn't change the functionality. But that will allow me to actually have a new string of that. We'll actually do simple arrays sa equal new, right? And after getting that simple array, I can actually just send my strings. There you go. So here, just to reuse the code, right? Let's try to be dry from the beginning. So I'm using the string array, just exporting it as a property from my simple array. And I can add that array directly to this new array list, right? Let's actually call this a string array list, just to have different name in there. Cool. And because of that, we can actually do something like this. And it's going to be really similar to what we did before. The difference will be that instead of giving the length, we can actually send the count. And for that, let me just go here. Let me do my complex array ca equal new. And let's on my complex array example, let's execute it. And let's comment this out. Oops. There you go. So let's just execute the other one, and we'll see that the count is still 3 items, right? The difference here is that we did instead of doing a count, we did a length, and with the list array we have a count. So we have a better one to actually have there. The cool thing about that one is that we can add, without any other issue, a fourth element. But let me put the correct name here. So with a simple add method, that will allow me to now have a count of 4. So we have 3 items at the beginning, and then we have 4. So with this, it's a lot of benefit. We're just able to dynamically change the list size. We're able to append a new element in there, and we can actually do the same to show the content. That will be pretty much like a simple for each, right? We can do a simple for each, and this was actually called Arraylist. So for every element in the Arraylist, we do this, and then we do the right line at the end. And we have all the elements that are shown there. And that's, yeah, I would say that that's actually better to say. Now, something that we can do this here, probably. Let's keep it like that. Let's not make it more complex than it is. So here we saw 2 different implementations of a non-generic one. The simple array and a little more complex like the Arraylist. The Arraylist have the same behavior. We can actually go through the element with this for each. And we can actually see those, or we can actually print it with a simple go to this particular index. And those collections allow us to have, there's a lot or more, what can I say, useful members or methods to implement. We're able to see the add range, that we send a traditional string, the add, that add a new element to this array, and go on and go on. But what is one of those limitations that we actually have this array? And what is why we sometimes we have issues here? Let me add another one, and let me add, instead of a string, let me add a number, and let me print the count again. We execute that. We have 5 items now. We can actually do console dot write line. Let's do string Arraylist 0. That actually, as I said before, we can actually access 3 indexes too. We should print first in there. Actually didn't print it. Why didn't print it? Oh, I didn't save it. My file is not saved. It's that little dot there. Let me save my file. Let me try it again. There you go. We have the first there. So let's go here. Let's actually print the element number 4, and this should be the number 5 that we set there. There you go. But because we actually able to do that, and we know that the first 4 elements are a string, and the 5th element is actually an integer, the way we add it through here. If we do a simple type of that, this is the way that we can do it. No. Let me try to remember who can actually do this type of role. Let's try to do this same function to display the content. And in order not to repeat ourselves, let's create it as another method. Let's do private void And let's call this print elements, right? And we're going to send something like this. So we need to send an array list, call it AL. Array list, we send it through here. So that means if we do here print elements, oops, why cannot send it through there? Oh, because it's actually called print elements. Sorry, it's not called PL. Oops, I'm not saving the element the way they're supposed to be. Okay, print elements. The argument given correspond to required format where we are going to send the array list. There you go. So we should be able to see first, second, third. Perfect. We add the fourth, and now we should be able to see the four of them. Yeah. We added the fifth, and we should be able to see an error. And that error is a invalid cast exception. It printed the first four, but when you get to a number 5, it gives an error. And you can see now one of the caveats, one of the problems to use a no generic element, that we are able to save different types in this list, and you can see in the book there are several types of lists. We have queues, we have stacks, right? This one is a specific array list, and whenever we have something as simple like print the elements, and we are thinking that all of them are actually strings, we need to be a little more dynamic about the typing in order to have those, in order to be what is need to be printed, right? So this actually gives us some kind of error in there. So because it gives that kind of error is where the actual non-generic fails for us. Also, if we want to do a little more advanced handling, or do we need to actually do a casting, in order to save that, probably we should be able to do some kind of casting in there, and that casting, but we allow us to move away from this, but that will add complexity to the code, and also that will add computational time for that casting. There are no how the way they say it is, there are no performance wisely to do. There are really heavy performance in there, and we allow us not to have a better way to have a code. And on the book we have a couple examples of boxing and unboxing and do casting, and I have that kind of explanation that actually tell you that in computational time to do that kind of assignments and those kind of casting diminish the application itself, and pretty much at the end it just giving us an issue that is not type safety, right? And because that, what we should be able to do, what actually implementation we need to have, we actually have the generic collections. Generic collections are, how can I say, it's a strong typed element that we allow us to specify what type of object is going to be inside of those collection itself. So let me just get up from here. Let me go back one level and let me do dotnet new. Let's call generic this one. Let's go to generic. Let me open it. Let me do yes here. And let's create a new file. Let's call it simple generic. And let's do what we can do here. Let's call this one. Oh, I cannot do generic example. Let's call this next page generic example. And let's do a class called simple generic. And for that one, let's do a public void example to be able to execute it. And let's get rid of all this using generic example. And let's do simple generic g equal new. And yeah, I know having variables named like this are no best practice, but for this example it should be enough. Let's call the example to be executed. Let me save that. Let me save this. Okay, let's do just to see that everything's working. Console.write line. Hello. And it's not working because I need to do using system. I had a typo there, sorry. Let me save it. Let me open my integrated terminal and let's do the .NET run where you see the gray line. Hello. Perfect. Okay, so let me show you a benefit of using generics, right? And we can actually have those strong typed. The first thing we need to import system.collections.generic. And we have a bunch of elements, and now we can actually specify a little better what we actually need. Let's actually put a public here, public and let's do a list. The thing about generic is actually defined to triangle bracket. I don't know how to call it, the symbol. And we need to specify, or we need to cast the type since the beginning. So if we can actually do something like this, public string, let's call it a string list get a simple get and setter, right? And let's do the default value being Now let's actually have it like that. So in the example, let's actually do to our string list, we can add first let's copy this a couple of times. Go to the second and third. So this will allow us to verify in our list. Let's do a simple console write line. Let's be a little more simpler. String list. We can actually do a simple count the way that we saw before. Right? That will allow us to have it's not, oh, I need to save it. String list adding count we handle assumptions to generate line 11. Why I didn't like it? Do we need to initialize this? Oh yeah, we needed to do an instance by default. There you go. I didn't initialize the list, so it's a new instance of a list of a string. Okay, sorry for that. So after I initialize the list itself, we're able to add elements and we can actually access the count in there. The cool thing about this is that in the string list now is strong typed. Will not allow me to add a number in there. It says the integer cannot be converted to string as an arithmetic element. So the one that who actually passed it in a simple array list, in a generic list cannot be done because we specify the typings at the beginning. So this typing is usually known, so it's usually see as T. We could actually say, you know what, about this typing is what I'm going to be sending you through this element. So when we try to do something like this, it actually fails. Right? It doesn't allow us to proceed with that. Let's create right here. And probably we can copy over from another one. Let me copy from interfaces. What we have here, RPG. Let's actually import our dragon. I just copy my dragon the way that we did in the past video. Of course, I need to copy the interface. I could delete it, but I just copy the interface to be safer. Public interface. There you go. Everything is there. So I can actually go to my simple generic and I can do let me use here using RPG, and let's do dragon. I can do, let's do as a property, something like this. Let's copy this, let's paste it. Let's call this my dragons. And let's actually do a leaf for dragon. Right? So because of that, we can actually start adding. We can actually do now to my dragons. I can add a new dragon. Let's call this Drogo. Oops, what am I doing here? We can actually have here, let's do it through here, sorry. Dragon, Drogo equal new, and we can add Drogo to the list, right? Perfect. Let's do dragon smoke equal new. And let's do dragon. What else? Let's do, I don't know, Shenron equal new. So I can actually do my dragons, add Drogo, my dragons, add smoke, and I can do now my dragons, add Shenron. So the cool thing is I was able to save 3 different instances of the class dragon in a particular list where I know that I can actually do different elements or implement different functionality inside that particular list. I can now go to a simple for each, and let's call this D in, and the collection, let's do my dragons, right? And let's do for every D dot damage, and let's do by 5. I don't know, something like that. Here we'll say that everybody will have a hit of 5. Oops. Let's do dotnet run. Let's see what happened here. Dragon health is 95, 95, 95, and we have the 3 different dragons names in there. Let's just go to here to the dragons, and yes, because we have the particular health for every one of those. So I can actually go through for each element, or I can actually go to my dragons, and I can actually see everything that we can actually do there. We can actually clear, we can see if contains, we can copy, equal, find all for each element. That will allow us to have a better understanding with this. and delegate to perform the action. Let me show you this. It's actually pretty neat. So we have a list of dragon for each action, dragon action. So the way to implement it, and let me check my notes really quick. We can do something really cool here. Like for every dragon on D, we do the fat arrow, and we do a console dot write line, and let's do D dot help maybe. Yeah, because the names that we have there. So we're able to access a property and do it through here. We can actually do something like this here, and that will work too. Something like this. So this for each is pretty much the same as this other for each that we have here. And it's another method to go to for every element. We assign it the D, and we just execute the damage by 5, and we can see that every dragon got hit by 5 in there. Because of that, we can actually do my dragons dot remove. I can remove a specific object, or I can remove a specific element, add, and I can just see an index. So let me remove 1. That will actually remove a small. A small actually is called it. Well, let's call it. dotnet run. Oh, we'll see pretty much the same. And let's do a simple what we have here. Let's check here. Let's do dragon list size is my dragon count, and after I remove one element, you will see the benefit there that we're able to add a new one, 3, and my dragon list size is 2 because we remove a particular one. Cool thing about this is we can actually do stuff like let's try to do my dragons dot find, for example, and we can actually do a match. Let's do for that match. Let me check my notes really quick. We can actually specify a little more specific elements that we need to actually have in there. So we can actually do something like, give me a second. And let me just, before we continue, let me actually change something here. Let me add public name, and this will be a string, of course. Let's do a simple get it setter. And let's call, we create this one, and we can actually do name equal draw. We can do this. Yes, because we're doing the perfect. And you can do here name equal to small. So here just initializing the object, and let me just change the correct name. And I think that's the correct name. I'm not even sure about that. And name equals Shenron. So with that, we can actually do find, and we send the dragon element. And now because all of them actually have a name, if dragon.name, we can, I don't know, something like contains, for example, draw. And let's do this, let's save it, and let's do a simple grab this in console.writeLine. Oops. WriteLine. Okay, let's see what happened. Yeah, we have our RPG dragon because we actually find it. And if we do, because we remove the element number 1, so that means smoke should not be there. Let's see what actually shows us in here. Nothing. So we can actually do let me do something like this. Let's call this a simple, what we can do. So you go for the instance of that particular dragon. So now I actually print the health, and let's see what it shows us in there. It shows us, yeah, it doesn't exist, it's not. But if I go to draw, it should print at 95, right? And now if I actually do and we know that draw is actually an element number 0. Actually, before printing that, actually let me do my dragons on this index 0. I want to damage by, I don't know, 50, for example. And now we can see Drogo health should be smaller. There you go, 45. We print it through here, and then when we see the health, we can actually retrieve that. And if I look for the health for Shenron should be 95. And Smog just doesn't exist, right? So there's benefits of having that kind of elements. We have findings through a specific property element, and you can do findings and you can do evaluation. You can do find the first one, find the last one. You can sort it. You can convert it to an array. You can do whatever you want, and that's one of the benefits of having those kind of lists here, and it's really, really cool. For the last thing before I close the video, what I want to show is it's a really cool example that actually the book gave us. It call it a swap function, and one of the benefits is to actually have a generic method on top of that. So let's create another one. Let's do what we can do here. Well, let's keep it the same one. So we have the example one, right? So now let's do a public void, and let's do swap And let's send a couple of, the example that they actually give us is a couple of integers, a, integer b. For those ones, let's actually do something really simple like this. This what it does is sends two variables, integers, and assign the value a to a temporal one, and then do the change. So the value of a go to b and the value of b go to a through reference. What does through reference? That the original value will be saved as it is. So let me show you that. Let me do simple integer first equal, I don't know, 3. Integer second equal 5. And then we call swap. And we're going to send first, second, and after we send those two, why I didn't like it. Oh, we need to send that reference. There you go. That way, when we send it to a reference, that means that we are pointing to this variable that are already here. So that means if I do simple console.writeLine, and let me do an empty one just to have that extra line. No, let's keep it like the way it's supposed to be. I believe we can do this one, and let's do space, and then do value of first is this first, value of second is, and we send second here, right? Something like that. If we execute it, we can see that the value of first changes to 5 and the value of second changes to 3, pretty much, right? We remember that we have Drogo be damaged a lot. Let's change the order, and we can actually do another something similar. We can actually send now, create the same one, but instead of integer, let me do something like this, something like this. Let's do a dragon. Okay. Let's swap two different dragons here, and we can do, and we need to send those as a reference. That way we can actually remove, change the one from here. So let me just swap let's do for my let's swap as reference, let's send draw, and as reference let's send chain run, right? And let's print the names. Let's send here, this one's here. Oops. And let's print name the second. This one over here. And this will be interesting. It's a pretty dragon name and second. Oh, yeah, of course. Because I do dot name. Forget that. Dot name. You see that Drogo actually changed it to chain run, and chain changed it to Drogo because we swapped them with these other functions that we have here, right? So far they are not generic function. Not generic. We set it still as a reference, but we need to specify the type of the value of the variable in this case that we actually send in, so we can actually do swapping here. The way that the book actually shows us, it's actually really neat. We can actually have a generic swapping when we pretty much we don't specify the type itself. We can do something like this. Let me copy this over again. And let's do some changes. And so far it's complaining, but let's actually make this something like that. And with that, we're just creating this a generic one. We are saying that we are going to send the type as T, and this can be anything, right? But I just put in like a T for convention. So because of that, whenever we send here, should be a T, and the T should be sent, right? In that way, we should be able, and let me just comment this out in order not to show it. Of course, it's going to complain. Oh, actually, it doesn't. And let's actually see it works like this. So we're able to use the swap with the typing, and whenever we send two integers, the swap happened, and whenever we send two dragons, the swap happened, but we use the same function. And this class is actually a generic method. This method allows us to specify the type, and in this case we are not specifying. C# is smart enough to understand it, right? But allow us to have a generic method that we understand what it needs to be sent and what it needs to be used. So just with that, this will pretty much swap any structure every time that this structure is the same type across the board. So we just comment this out, and without any other change, these two swapping are using now the same method as we saw it over here. Okay, this is a really, I tried to be as fast example, it took like an hour for the video, but I really hope that you like it. I know it's a little more complex to understand it. Go through the book, go through the examples that are over there, go through the examples from the book that I will give you the link, and I hope that this video also help you understand a little bit better. But remember, if you have any issue, any doubt, just don't hesitate to reach me. Happy coding, everybody.